Okay, so basically my name is Paul. I'm a PhD scholar under Yamoda. So today I'll share the screen, my entire screen. You can see my screen, right? You can see my screen, right?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes.
have you downloaded Weka tool? Have you guys downloaded the Weka tools?
Yes, sir.
So everyone has Weka tools, right? I'll just send you the link. So from this link you can download. Just go to this link, then go to download. Then from here you can see Windows, Mac, or Linux. So you can go here and click here, then you can download. So I'll just start right away, okay, if you have already downloaded the Weka tools. So yeah, if you open you'll see the interface GUI like this. So in last class I think Surya has told you about what is data mining and why we use introduction to Weka, right? So this is a data mining class, so I'll be just going a brief introduction, just a brief on like what are the packages or what are the things available in Weka. So it's just a introduction to the Weka tools. So you have to explore by yourself. So basically data mining, we all know that it's a process of discovering the patterns in a large data sets or extraction of unknown information from the data. So there are different tools and Weka is one of them. So Weka is a open source tools. So it's I think it contains different tools. It contains pre-processing, classification or regression, and even association, and for visualization. So we have here, we have Explorer, Experimenter, Knowledge Flow, Workbench, Simple CLI. So we will be basically using this Explorer. So this is a graphical interface where you can do data mining or pre-processing. So, and this one, Experimenter, allow user to execute different experimental data variation, different data. And this one, Knowledge Flow, it's basically drag and drop type functionality it has. And this one, Workbench, it's a combination of all this Explorer, Experimenter, Knowledge Flow. And this one, Simple CLI, it's based on command line. So Weka works on Java based. So if you are good at Java, you can use command line too. But we'll be using, mostly we'll be using only on Explorer. So this is just a brief introduction to data mining only. So for if you want to install other packages also, like there are different packages, right? Even if you know R or Python, we import the packages to the tools, right? To R or Python also. So here also Weka also has got tools. So if you go to tools and click on package manager, yeah, then here is a search box. So you can search a particular tools. Like suppose I'll just write something SVM and I'll give enter search. So you can click the package select the package, then install. You want the following package to be installed or upgraded? Yes. Okay. Then see it's installing. So, and you can go for like documentation from this link also. What is that package used for, and all those command line or whatever, like what are the function they have in the package, so you can see. You can go to link and you can see. I'll just cancel. Okay. So after install, you can see, like, see, and it will appear automatically to the package library. So we'll go to the Explorer. So we have a different tabs here. Pre-processing. Then next is classify. That is for classification. Next tab we have a cluster, associate, select attribute, visualization. Under different tab, they have a different machine learning algorithm, pre-implemented machine learning algorithm you can implement into your data. So we have so basically pre-processing is a prerequisite step in data mining that is needed to make data more suitable for mining. So here we usually remove redundant or irrelevant or noisy, that is outlier data, or incomplete data like missing value and inconsistent data. Pre-processing we basically do. And we also use pre-processing we use for data cleaning also, data integration also, data transformation also. So in this Veka, we have two filter packages. We have two filter. We have a supervised and unsupervised filter. Then under supervised and under unsupervised, we have attribute filters. We have attribute and instance. So supervised, basically, it's used for like discretization, and in unsupervised we mainly use for replacing the missing values or numeric transformation. So I'll just show you, and these are the tab we have. See, open file. You can see my arrow, right? We have open file. Here you can load the data from your computer local system. You can also load the data from your website if you have the link, or open from the database also. And let's just open one data, okay? Suppose if you have installed Weka, if you have installed the Weka, inside the Weka folder, there will be data. Can you see data? Inside the Weka folder which you have installed, under that directory, you'll have a data. Those are example data. So we'll be using those example data. Okay, you can check out in your system also. So we have different data sets. So these are the file formats Weka supports. So here we have mostly ARF data file format. Then I'll show you ARF file format. Okay. So this is the data example data they have given. So if you open, I'll open one data file. So this is the file, how it looks. ARF file format. It also supports CSV. So see, this one relation. This is the relation weather dot symbolic. This is the data set name, and these are the attributes: outlook, temperature, humidity, windy. Then these are the under at the rate data. These are the observation table, or we call it as instances. And this one is known as target or class variables. So we'll just load weather data. Okay, there are two data set, numeric. So I'll just load weather numeric.arf file, okay? So these are the data we have. See here, it is given instances 14. That is the number of row of a data called instances. See, if you go to the edit and see the data. So here it says instances 14. We have 14 observation tables. We have 14 row. So that is the instances. Then attributes is the column data. That is the features like outlook, temperature, humidity, windy. These are the attributes. And suppose outlook. See here the types are given, right? Numeric type. If we select outlook, nominal. So nominals means it's a categorical data like yes or no, sunny, outcast, rainy. Those are categorical data are called nominals. Or see yes or no, nominal. Humidity. See here the observation table, if you go for the instances like see under humidity, it's given into numeric form. So those that are represented in numbers are called numeric, and nominal will be in categorical values. So then if you go here, see temperature, and we have unique 10, right? Unique 10. So that is the number of the instances in the temperature the data having a value from this attribute that no other instances have. So there are 10 unique values. If you open and see 85, 80, 83, 70, say 75 and 75 are repeated, right? We have 14 instances, so others are unique. So we have 10 unique instances. So like that. And here see, in this Veka tools, you will see they will give details about missing data also. So missing 0. In our observation, there is no missing values. So if there is missing values, you can use some filters or you can add. And here, if you edit, here you can edit by, you can manually edit also. Or else you can add one more instances by here clicking to add instances. Undo, cancel. So that is just a type of. So we have attribute filter and instances filter, right? So under see attributes, that means filter. That means this apply operation to all the attributes or one attribute at a time, okay? So if you apply this filter attribute, it will apply to the whole attribute or one attribute at a time. And if you select, if under instance, it apply, the operation apply on instances or one instances at a time if you apply those filters. So that's so there. Then we have miss. So let's just go first to missing values. So in this data, I think we don't have missing values. So we'll choose other data. Okay. Open file. We'll select breast cancer data. Open. Age 0% missing values. Menopause 0. Say if you go to node cap fifth instances, if you go to the fifth one, you see there are 8 missing values. So just edit, go see. These are the missing values we have, see here. Then we have other missing values also, see. You can see, right? So select. We'll apply missing. Apply. Filter. We'll go to filter. Then go to unsupervised. Since it's attributes, under attributes, then we'll go under attribute. Then we'll apply replace the missing values. So if you click here, you can go through the details. Also, I just apply the default settings, okay? So I already apply. See now if you go to instances fifth node cap, so we have already fill. So there is no more missing values. See here it is written, replace all the missing values for nominal and numeric attributes in a data set with modes and mean from the training data. So basically they are replacing the missing values with the mean of that data. So this is one pre-processing method for filtering out the missing values for adding. Or you can, if you don't want those instances which has missing values, you can select and delete also. You can clear, delete selected instances by clicking right click, or if you want to replace the missing values, you can use this filter, replace the missing values. Okay. Then one is, let's just take another data. Suppose, let's just take weather numeric data. So we have weather numeric data. Suppose temperature, see temperature is in 85, 80. So we want to normalize this temperature under like certain scale. So normalization is a process of rescaling the attributes into a range. So I think this WECA by default, it takes a range from 0 to 1 default. So we'll just apply the normalization on the temperature. Just select the temperature. Go to filter. Then we'll go to unsupervised. Then under attributes, we'll use the filter normalize. So we are normalizing 0 to 1. So apply. So if you look at the instances, see now it has been normalized to 0 to 1 scale. Highest is 1, then lowest is 0. So in this way, you can do normalization using Weka tools. Okay, you can do undo also here. The button is the undo. So just I'm showing you what are the filters available. You have to explore by yourself. Like just this is an introduction. Like what are the things available or what things you can do. This is a easy things. Now we have let's convert nominal to binary. Since this is a numeric data, we can convert numeric data to nominal data also and nominal to binary data. So just let's take temperature, right? Okay. So we can, if we want to convert to, this is numeric data, right? Numeric to binary, so we can convert numeric to nominals, we can convert. So apply. So we can convert the nominal attributes to binary also, and numeric to nominal also. So based on what you need, you can convert those. Then suppose if you want to discretize the instances, you can also do that. Or if you want to remove the misclassified one, you can remove the misclassification. Suppose now we are not going for classification, okay? Classification will be other class. So just suppose we took one data. Just I'll show you the data. Let's take diabetes data, which has more observation. So suppose just we are going for classification. Go to classified tab. We use suppose let's just take random forest and default value like. So here we have see incorrectly classified instances 186 and that is 24%. So if you want to remove the misclassified one also, you can do pre-process, go to pre-process tab, go to the filter. Am I going too fast? Hello?
Yes, sir. Could you bit slow down?
I'll show you the slide, okay, after this.
Not only that, Paul, you are going a little fast and also your voice is very feeble. Please make it
After
little
this,
louder.
yeah, after this, I will show you the same
Yeah, now it's better.
same thing in the slide, okay? So if you want to remove the misclassified, so see here we have a classified 24% misclassified, right? So if you go to pre-process tab, open the filter, go to the filter, choose, go to unsupervised. Under unsupervised, you go to the instances. Then under that, remove misclassify. Then just I'm using the default value only, okay? Just apply. And if you go back to the classification, And one more time you start. So see here, now it's showing incorrectly classified instances 0%. So in that way also you can remove the misclassified instances. And one more, we have a discretization. Discretization is just a way of transforming a continuous attributes like number 1, 2, 3, 4, 5, 6, like 1 to 10, we have a number. So we are trying to transform the continuous attribute into a categorical attribute type. So we're dividing like group 1, group 2, group 3 into like 5 to 1 is one group, 6 to 7 is one group, 8 to 10 is one group, like that. So there is also a filter for discretization also. So we'll take for discretization, we'll take diabetes data. Let's take diabetes data. So this is the loaded diabetes data. We'll go to filter. Okay. Suppose, yeah. Go to filter, unsupervised instances. Supervised instances. Yeah, here we have discretized. If you are, this is the data. So it will form into group. If you apply, so see, it has been grouped. It has been categorized into different category attribute. So that is also one discretization filter we have. Then one way is to filter out the outlier, that is extreme values. So we will choose other data. Suppose, just let's take the same data. Open file. Open. Then first go to unsupervised. Let's go to attribute. So we are setting we are using the interquartile range. Interquartile range. Apply. So see here, one instances is there. So it's reporting the outliers. This filter add new attributes that is indicating the value of the instances that is considered to be outlier or extreme values. So we have 49 extreme values. So we can remove the values by going to, again, we go to choose unsupervised. Under unsupervised, go to instances. Go to instances. Remove with values. Remove with values. Then filter here. So our attribute index is number 10, right? So we'll just write 10. Then normalize indices. Last. Okay. Then apply. So we have removed the outlier of extreme value. So it's showing here, see, here it's showing yes, 0, count. These are some of the filters we have. So I'll just share. So what we did was it's a part of data mining. Data mining is we all know that it's a part of process of discovering the patterns in a large. So we have different data. We have different tools. So we are using Weka as to. We are using Weka since it's open source, easy to use, and it has graphical user interface. So we are using this. So it's a tool developed by University of Waikato in New Zealand. So under this Weka, we have pre-processing. You have seen, right? Pre-processing. We have classification tab also. We have clustering tab also. We have association rule, and for visualization, we have. And we have 5 interface. One is Explorer. That is graphical user interface. One is Experimenter, allow user to execute different experimental data. One is knowledge flow, that is using drag and drop method. One we have workbench, that is combine of all this Explorer, Experimenter, and knowledge flow. And third is simple CLI, that work based on command line. So I have shown you how to install the packages in Weka. Just go to the tools, package manager. Then in the search box, you type the package name. Then you select. Then you go to install. So data pre-processing. In data pre-processing, we are trying to remove the redundant or irrelevant or noisy data or incomplete data and inconsistent data. So we have a different tab, pre-processing, classify tab we have for classification, and we have clustering tab also. There under clustering, you have different machine learning algorithm for clustering. Then association, you have different association. You have different machine learning that you can implement. And we have select attribute and visualization. So we are exploring on pre-process tab. So we have a different data type. It supports CSV data file also. So which we are using was ARF file format. So in ARF file format, we have seen the data set name. We have next is we have attributes. That is different features. Then third, we have instances, data value, that is observation. So instances is a row of data. Row of data is called instances. That is the observation. These are the instances we have. Under weather data, we have 14 instances. So attributes is a column data, that is like the outlook, temperature, humidity, windy, play. These are the attributes. Then we have 2 data types, nominal or numeric. Nominal is a categorical data type like yes or no, true or false, sunny overcast, rainy. These are the nominal data type. Numeric is instances in number. Then we have here we have a distinct is a number of different values that the data contain for these attributes. So that is the observation in the instances that is not repeated. So here we have 12 distinct. So 75 are repeated. So we have only under 14, we have 12 distinct values. Then unique is a number of instances in the data having value for this attribute that other instances doesn't have. It's the same thing. Then we have supervised and unsupervised. Under supervised, we have attribute filter and instances filter. And under this unsupervised, we mainly use for replacing missing value and numeric transformation, binary to numeric, numeric to binary. And under supervised, we mainly use for selection, discretization, and instances filter are for resampling. Then in attribute filter, we apply to the whole attribute at a time or one at a time. For instances, we apply to the instances or one instances at a time. So under missing values, you can use under unsupervised filter, missing values filter is there. So this is just trying to replace the missing values, or you can remove by deleting the instances. And we have a normalization also. It's a process of rescaling to certain, you can, in a filter, you can change the range. This is the default value 0 to 1. So in there, you can remove the ranges. See here, this is the value. It's given in 2-digit number. Then if you normalize 0 to 1, you will see 1 as the highest, 0 as the lowest, and you can normalize like that. So then we have we can convert nominal to binary data also using unsupervised filter. If you need to carry out, if you need binary data, you can convert. If you want to convert numeric data to nominal data, so you can convert under same filter unsupervised attributes. Then we have seen remove misclassification. If suppose you are classifying, and if there are wrong classification under pre-process step, you can also remove misclassified one under unsupervised and by removing the instances. Then we have discretization. Also, if you want to transform the attribute into a categorical attribute, suppose we have a continuous number. So in discretization, we are grouping like this: S1, S2, S3, 5 to 5.9, 6 to 6.9, 7 to 7.9 simple length. So we are transforming the continuous attribute into categorical attribute in discretization. Then for filtering out the extreme values, you can also use interquartile range, filter the new attributes, which whether the value of instances can be considered outlier or extreme values. So if you want to remove those extreme values, you can go to the filter, remove with values, and you can filter. So that's all. I think you can explore. This is just a brief introduction to the pre-processing tools in Vecka. I think you can explore if you do by yourself. Since this is a graphical user interface, so it's already there, those data. It comes with the package of this Weka, so you can upload the data, then you can choose different filters and you can see. If you practice more, you will know more. So we are just trying to introduce you to the Weka tool. So you have to do by yourself mostly. Any question like? Anything you want me to repeat something?
Can I interrupt, Paul?
Yes, ma'am.
Yeah. Thank you, Paul. First, I should tell the students the first four in the attendance. The first four in the attendance, one batch, and the second four in the attendance, altogether 8 students, should do this exercise. And next class, you have to tell me the result, whatever you explore. All others can also explore, but these 8 candidates, 8 students should take different data, or else I can say the whole class can take different data and you can tell us the result and you can ask the doubt what you want to ask, because this exercise is given. Whatever the pre-processing has been handled today need to be explored, otherwise you will not have any questions in your hand right. Am I right, students?
Yes, ma'am.
So
Yes,
as
ma'am.
we explore the tool with the exercise, all students in the class MSc and with the different data, if you can make your batch or randomly you can select and check. MSc can check the first for something like that. You discuss among yourself and take different data, explore, come with the doubts and come with the answer. Now, if you want to ask something, you can ask.